Hi guys, welcome back. So today we're going to be looking at our second day of exponent rules and sort of exploring where they come from. And this rule is called the power rule. And what we're basically looking at is what do you do when you have something that has an exponent and then it's being raised to another exponent. So if we were to write this out the long way, here's what it would look like. 3x to the fourth times another 3x to the fourth times another 3x to the fourth, which means I would rewrite this in an expanded way as 3, so this first one would become 3 times x times x times x times x. The second factor here would become times 3 times x times x times x times x, and the last factor here would become times 3 times x times x times x times x. Now if I put together the things that seem to go together, for example, if I combine the 3 times the 3 times the 3, 3 times 3 times 3 is 27. And now if I put together the x stuff, which all kind of seems to go together, let me see if I can find a different color pen. We're going to have 4 x's here, and 4 more x's here, and 4 more x's here. So we would have x to the 12th, because 4 plus 4 plus 4 is 12. So if we look for a pattern, so how could we get from our original question to this one without writing it all out in the middle steps? If we look for a connection, what I notice is that it seems like this exponent was multiplied into all the factors that were inside. So for example, it seems like I took the 3 and I distributed it, just like I usually do with numbers that are outside of parentheses, and I got 3 to the third, and then I got x to the 12th, because 3 times 4 is 12. Now to check to see if that's true, I need to know what 3 to the third is. And it turns out that 3 to the third really is 27x to the 12th. So it seems to match what I expected to get when I wrote that out. The pattern here is that when a power is being raised to another power, we multiply the powers together. I like to think about this as the distribute rule, because to me, this reminds me very much of what we used to do when we distributed numbers that were outside of parentheses into the parentheses. So let's take a look at a way to write this rule. When you have x to the m being raised to the n, you just multiply the powers together. So you take these two powers and you multiply them together. I like to think about that as distributing. Let's see if we can do another problem and work it out in a similar way. So if I have this problem, one way to write it out the long way would be to write 4x squared over y to the fifth times 4x squared over y to the fifth times 4x squared over y to the fifth. If I wanted to keep expanding that, it would look like this. The first term would get expanded and would become 4 times x over y times y times y times y times y. The second term would get expanded and it would become 4 times x divided by y times y times y times y times y. And the last term would get expanded and it would become 4 times x divided by y times y times y times y times y. Now, if I just group like things together, the 4 times the 4. I'm just going to go straight across the fractions. The 4 times the 4 times the 4 would be 64. There are 2 x's here, and then there are 2 more x's here, and then there are 2 more x's here. So 2, 4, 6 makes x to the 6th. And on the bottom, I'm going to have, there are 5 copies of y here, and 5 copies of y here, and 5 copies of y here, so I'm going to have 15. Now once again, it's kind of the same pattern I noticed before. What I really did is just distribute the 3, the third power, to all of these exponents. So I got 4 to the third, x to the 6th divided by y to the 15th. And if I type 4 to the third power into my calculator, I get 64. So that's where that number comes from. So rather than write the whole rule out again, we're just going to say it's the same rule that we had before. It's just that it even works for division now. So if you have x to the m divided by y to the z all to the nth power, you would just distribute that power to everything that's on the inside, and you would have x to the m times n over y to the z times n. So let's look at some application questions where not application, but sort of problems that I could ask you to do to use this rule. So there's only 4 of them this time. If we answer the first question using the rules, here's what I would do. I would take the 6 and I would distribute it to each of the factors inside of the parentheses. That means I even need to distribute it to the 3. So when I distribute it to the 3, I would get 3 to the 6th times x to the 5 times 6 is 30th. Then I would simplify this. So 3 to the 6th, if I type that in on my calculator, 3 to the 6th is 729. X to the 30th. Now if I wanted to write this out the long way, it would look like this. 3x to the 5th times 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 3x to the 5th, 1, 2, 3, 4, 5, times 3x to the 5th. Oh my gosh, so many. Now another option that we have is if we do want to write it out the long way because it helps us figure this out better, we could, instead of continuing to expand, use one of the rules we practiced yesterday where we can just add the powers. So I would deal with the numbers first. 3 times 3 times 3 times 3 times 3 times 3. There are 6 of them, so I would have 3 to the 6th. Then I would look at the x's. If I add the exponents together, I would have 5, 10, 15, 20, 25, 30, so x to the 30th. And then I already typed it in. I happen to know that 3 to the 6th becomes 729, x to the 30th. Now I'm going to tell you this is why these shortcuts were invented, is that we want to make these problems a little bit easier by not having to write them out all the time. However, if you're doubting yourself and you're wondering if you got them right or wrong, that's the time you use the long way to make sure that you actually got the answer right. Let's take a look at problem 2. If we were to do this problem using rules, we would just distribute the power of 4 to all of the other powers, including to the 2. So I would have 2 to the 4th, x to the 20th, divided by y to the 28th. And then I would be able to say, well, I happen to know that 2 to the 4th is 16. So I would have 16x to the 20th divided by y to the 28th. Writing this out the long way would really be a bummer, but we could do it. We could write 2x to the 5th divided by y to the 7th times 2x to the 5th divided by y to the 7th times 2x to the 5th divided by y to the 7th times 2x to the 5th divided by y to the 7th. Then, because of the way that rules work for fractions, I would just go straight across the top and straight across the bottom when I'm combining. So if I combine on the top, I'm going to have 2 times 2 times 2 times 2, which is 2 to the 4th. I'm going to have x to the 5th times x to the 5th times x to the 5th times x to the 5th. So 5, 10, 15, 20, which is x to the 20th. And on the bottom, I'm going to have y to the 7th times y to the 7th times y to the 7th times y to the 7th, which is y to the 28th. Then I would type in 2 to the 4th power on my calculator, and I would get 16x to the 20th divided by y to the 28th. Either way, I get the right answer. It's just a matter of which way is going to be the more efficient way to do the problem. All right, now, what if we want to try these problems and not do it the rules way? Well, it's totally acceptable. You can definitely do that. So if I do problem 3 without using the long way, I just want to use the rules, I would just distribute the 3 to all of these powers, including to the 4. So I would have 4 to the 3rd times x to the 21 divided by x to the 15. That would simplify if I simplified the 4 to the 3rd. Now 4 to the 3rd, I'm typing it into my calculator, is 64x to the 21 divided by x to the 15. But here's the problem. I can't stop here. This is an example of a problem that requires me to keep going to simplify. And the reason I know I need to simplify is because I still have a base of x and a base of x in this same problem. We should be able to simplify that by combining. Now, this is a division problem, and I know that when I'm dividing, the rule for dividing is that you just subtract the exponents. So I'm going to go ahead and do that, and I'm going to get 64x to the 6th, because 21 minus 15 is 6. Now let's write it out the long way and see what we could figure out from doing it the long way. So if I write this out 3 times, times 4x to the 7th divided by x to the 5th, times 4x to the 7th divided by x to the 5th. Now if I keep expanding this, because I want to show you why we still have to simplify, if I keep expanding this, I end up with 4 times x, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, yeah. And 5 of them on the bottom. And then I end up with 4, and then 1, 2, 3, 4, 5, 6, 7, and 5 of them on the bottom. 2, 3, 4, 5. And then I have 4, and then I have 1, 2, 3, 4, 5, 6, 7. And then on the bottom I have 1, 2, 3, 4, 5. Now when I write it out like this, I think it makes it more obvious that definitely some stuff cancels here. 5 of these x's cancel. 5 of these cancel. 1, 2, 3, 4, 5. Which means I only have 2 x's left here, 2 x's left here, and 2 x's left here. So if I multiply the 4 times the 4 times the 4, I get 4 to the 3rd, and then 2, 4, 6 x's left, and 4 to the 3rd becomes 64. X to the 6th. We're going to go ahead and save the last one for if we need to go over another question tomorrow. Thank you so much for watching. I hope that this is making more sense, how this is connected to writing it out the long way, and we will practice this tomorrow. Have a great night.